Jai Hind students, welcome to my YouTube channel. Students, do not let what you cannot do interfere with what you can do. I repeat students, do not let what you cannot do interfere with what you can do. What I mean to say is that, students, you all are capable of doing infinite things. It's only the desire, it's only the burning desire that should come from within yourself. And in order to fulfill your desire, in order to fulfill your dreams, you need to put in concentrated and dedicated effort. And every dreams of yours can get fulfilled. So students, with that, let's start with this particular session. In the previous lecture, we have discussed about vectors, then we have discussed various types of vectors. In this session, we will be discussing the multiplication of vector by a real number. And then we will also discuss how the vectors are added in different cases. And in the meantime, we will also discuss some basic laws of vector addition. We will try to discuss triangle law of vector addition, parallelogram law of vector addition, right? So, without wasting any time further, let's start with multiplication of vector. So, our first topic is multiplication of a vector. Suppose this is a given vector, a vector, and it is to be multiplied by n. N is any real number. It is any real number. It can be positive or it can be negative, right? So when this given vector is multiplied by n, which is any real number, then the resultant will be, say, r vector, and it will be given by n times a vector. That is, when a given vector is multiplied by any real number, then the resultant will have magnitude n times the magnitude of the given vector, and will have direction either along the given vector or opposite to it, depending whether n is positive or negative. For example, if n is equal to 2, then resultant, it will be equal to 2a vector. In this case, the resultant will have magnitude twice the magnitude of a vector and direction same as that of a vector. So in this case, the resultant would be somewhat like this. This is r vector. It will be equal to twice a vector. Its magnitude, its length is twice that of a vector and parallel to it. That is in the same direction as that of the given vector, a vector, right? While on the other hand, if suppose n equals to, say, -3, then resultant, it will be given by -3a vector. What this statement means is, the magnitude of this resultant is equal to three times the magnitude of the given vector, and negative sign suggests that its direction is opposite to that of the given vector, right? So opposite means anti-parallel, make an angle of 180 degrees. So this is a given vector. So the direction of the resultant in this case will be in the opposite direction, and 3 times. So it will be like this. So this is r vector, which is equal to -3a vector. So what I've tried to do is, I've tried to draw an arrow of length twice the length of the arrow indicating a vector, but in the opposite direction. So that is how a vector, when multiplied by any real number, will give a resultant which will be equal to, whose magnitude will be equal to n times the magnitude of the given vector, and will be directed either along the direction of the given vector or in a direction opposite to that of the given vector, depending on whether the value of n is positive or negative. Clear, students? And here I must again mention a very important fact, that when a vector is multiplied by a scalar, then the resultant is always a vector quantity. Always remember that. I repeat, whenever a vector is multiplied by a scalar, then the resultant is always a vector quantity. Clear, students? So we are done with multiplication of vector with any real number. It can be both positive or it can be negative. Now let's discuss addition of vectors. So in the topic of addition of vectors, we'll consider various cases. Case 1 will consider when the two vectors under consideration act along the same direction, right? So let's discuss the second one, which is the addition of vectors. Addition of vectors. We'll discuss various cases. Case 1 is, let's consider case 1. Case 1 is when the two vectors under consideration are acting in the same direction. That is, vectors acting in the same direction. That is, angle between them is 0 degree. So, we are dealing with this case. Suppose this is A vector plus this is B vector. Now, it is a common sense thing, right? So, when the two vectors are acting in the same direction and if they are added, then the resultant will have magnitude of the sum of the magnitude of the two given vectors and will be directed along the direction of either of these two vectors. Clear, students? So its resultant would be like this. If this is 5 centimeter, this is 2 centimeter, it will be 7 centimeters. So it will be R vector is equal to A vector plus B vector. So in magnitude, resultant, it will be given by sum of the magnitude of the two given vectors and direction would be along either A vector or B vector. Both are in the same direction. Clear, students? It's very simple. For example, this is a body and it is acted upon by two forces. This is suppose 2 Newton and this is suppose 1 Newton. Now both the forces are acting on the body in the same direction. So it is but obvious. What is the net force acting on the body? The equivalent diagram would be like this. This is the body and net force acting over here, it would be 3 Newton. So the point to be noted is that if the two vectors are acting in the same direction, then the resultant would be given by the sum of the magnitude of the individual vectors. And obviously, the direction of the resultant will be along the direction of either of the two vectors. Clear? That's very simple. So this is in one dimension. That is when the two vectors are acting in the same direction. They are acting along the same straight line. Right? Now let's consider case 2. Case 2 is when the two vectors are acting in the opposite direction. So case 2 is vectors acting in the opposite direction. That is when theta is 180 degree. So we are dealing with this particular case. This is suppose A vector plus this is B vector. Both are oppositely directed. So what's the angle between these two? 180 degree. So what will be its resultant? When the two vectors are acting in the opposite direction, they are opposing each other. In the previous case, when they are acting in the same direction, they are aiding each other. But in this case, they are opposing each other. So it is but obvious. The resultant will have magnitude, which will be given by the difference in the magnitude of the two given vectors. And obviously, the direction of the resultant one will be along the direction of the dominating vector. Here, I have shown A vector to be larger than that of B vector in magnitude. So A is the dominating one. So the direction of the resultant in this case would be along the direction of A vector. Right? So what we get is, in this case, if it is 5 centimeter, it is 2 centimeter, then resultant will have a length of 3 centimeter along the direction of A vector. So here R vector, it will be equal to A vector plus minus B vector. Or simply you can write A vector minus B vector. Clear, students? So in this case, the magnitude of the resultant would be given by A vector minus B vector. So in this case, the magnitude of the resultant when the two vectors are acting in the opposite direction is given by difference of the magnitude of the two given vectors. A vector minus B vector when A vector is greater than B vector, and it will be B vector minus A vector when B vector magnitude is greater than the magnitude of A vector. Clear, students? And as I have told you, in this case the direction of the resultant will be along the direction of the dominating vector. In this case, when the magnitude of A is greater than B, then resultant will be A minus B along the direction of A. In this case, if B is greater than A, then the magnitude would be B minus A along the direction of vector B. Clear? So let's consider an example. Suppose this is a body over here. A force of 5 Newton is acting along this direction, and a force of 2 Newton is acting in the opposite direction. That is, the angle between them is 180 degrees. What is the net force acting on this body? Just consider the case of tug of war. If the rope is being pulled by a larger force along that side, obviously it will have a net movement on that particular side, along the dominating one, isn't it? Here, which is the dominating force? Obviously 5. It is larger than that of 2. So both are opposing each other, but 5 Newton is more dominating one. So the resultant would be 5 minus 2. That is 3 Newton along the direction of the dominating, which is 5 Newton force. So the equivalent diagram would be like this. This is the body, and the net force acting would be 3 Newton along the direction of 5 Newton. So what's the conclusion? When the two vectors are acting in the opposite direction, then the magnitude of the resultant is given by the difference in the magnitude of the given vectors, and the direction of the resultant will be along the direction of the dominating one. Clear, students? So these are the two one-dimensional case. That is, when the vectors are either acting along the same direction or they are acting in the opposite direction. So we have discussed two cases, when theta equals to 0 and when theta equals to 180. These are basically simple cases, right? Now we will discuss case 3. That is, if the angle between the two vectors whose resultant is to be determined is theta, it is neither 0 degree nor 180 degree, then how to vectorially add those two vectors? So for that, we make use of laws of vector addition. And for that, we need to study triangle law of vector addition. And then we will study parallelogram law of vector addition, which is actually the extension of triangle law of vector addition only. Right? So, case 3. Case 3 is when A vector and B vector are inclined at angle theta. When A vector and B vector are inclined at angle theta, right? So this is the case. Suppose this is A vector, and let us consider this to be B vector, and the angle between them is theta. This is the angle between them. Look, students, you should be aware of the effective angle between any two given vectors. The vectors must emanate from a common point. That will be the effective angle. They should either emanate or they should terminate at that particular point. So that would be the effective angle. Right? I'll clarify it. Suppose this is the case. This is A vector, and let us consider this to be B vector. And suppose this angle is 120 degree. If I ask you, students, what is the angle between A vector and B vector? It is obviously not 120 degree. Actually, the angle between A vector and B vector in this case is 60 degree. I'll tell you how. At this point, A vector is getting terminated, while B vector is emanating or starting from this point. What I've told you is, the angle between the two vectors must be considered when both the vectors are terminating at a particular point, or both the vectors are emanating or starting from a particular point, right? Here one vector is ending at point, while the other vector is originating from that point. So this is not the effective angle. This is not the effective angle between A and B. Actually, if you draw an equal vector, A vector over here, then it will be like this. This is A vector. This is an equal vector. Equal vector means having the same magnitude as that of the given vector and in the same direction as that of the given vector, right? Now in this case, both A vector and B vector are originating from point O, isn't it? Both A vector and B vector are originating from point O. Therefore, this must be the effective angle between A vector and B vector. This being a linear pair, if this is 120 degree, this would be 60 degree. So students, I hope you have understood this concept. Right? It's a fundamental or basic thing. We need to understand the angle which is the effective one between the two given vectors. So in this case, the angle between A vector and B vector is not 120 degree, it is actually 60 degree. So the angle must be measured in such a manner that both the vectors must emanate or start from a particular point, or both the vectors must terminate at the given point. Clear, students? So here, theta is the angle between A vector and B vector, because both the vectors are starting or emanating from the same common point, right? Okay, coming back to this, we have discussed in case 1 how the two vectors can be added vectorially when they are acting in the same direction. Then in case 2, we have discussed how the two vectors get added vectorially when they are oppositely directed along the same straight line. Here we need to discuss how the two vectors are added vectorially when they are inclined at each other at an angle theta. Theta is neither 0 degree nor it is 180 degree, right? So in such a case, what we do is we make use of triangle law of vector addition. We make use of triangle law of vector addition. Now look, this is a basic or fundamental law of vector addition. So this is a basic law of vector addition. There are some other laws as well, like parallelogram law of vector addition, then we will discuss polygon law of vector addition, but those are the laws which are extension of this law. So that is the reason why triangle law is considered to be the basic law of vector addition, right? Now let's concentrate on its statement. Triangle law means we have to represent these two vectors which are acting simultaneously at a point by the two sides of a triangle taken in the same order. So for that, let me first draw it or explain it graphically. So this is point 2. Let's draw A vector. This is A vector. Now move this B vector parallel in such a manner that its tail coincides with the head of A vector. So I will draw an equal vector over here, right? This is B vector. This is B vector. These are the equal vectors, right? So this will be the angle theta, right? This is the angle theta. So this vector can be redrawn in this particular manner. Both are equal vectors. Both are of same magnitude and in the same direction, so they are equal vectors, isn't it? Now look, if the two vectors acting at a point simultaneously be represented by the two sides of a triangle taken in the same order, then their vector resultant both in magnitude and direction is given by the closing side or the third side of the triangle taken in the opposite order. So this will be the resultant. This is the third side of the triangle taken in the opposite order. So this is R vector, which is vectorially given by A vector plus B vector. So this is the statement of triangle law of vector addition. I repeat, students, please concentrate, right? The statement, you need to remember it. It's a very, very basic thing and very important one. It's a very, very important one. So, triangle law of vector addition is the basic or fundamental law of vector addition, right? This law states that when the two vectors acting on a point or a particle simultaneously be represented by the two sides of a triangle taken in the same order, then the vector resultant both in magnitude and direction will be given by the closing or the third side of the triangle taken in the opposite order. Now look, A vector, B vector, these are the two sides of a triangle taken in the same direction, that is in the anti-clockwise direction. So the vector resultant would be given by the third or the closing side taken in the opposite direction, which is the clockwise direction. Clear, students? So I'll write it. The main part I'll just again convince you. So it's a basic law of vector addition. Then two vectors acting simultaneously at a point, right? These two vectors must represent two sides of a triangle taken in the same order, or same direction. Then resultant is given by third side. Third means closing side of the triangle taken in the opposite order, of the triangle taken in the opposite order or opposite direction. Right, students? So we'll discuss its analytical treatment as well, where we'll be discussing all the possible scenarios, right? So let me again state it, right? Triangle law of vector addition is the basic law of vector addition. This law states that when the two vectors acting simultaneously at a point be represented by the two sides of a triangle taken in the same order, then the vector resultant, both in magnitude and direction, is given by the third or the closing side of the triangle taken in the opposite order. So by using triangle law of vector addition, we can determine the resultant when A vector and B vector are inclined at an angle theta. Clear, students? So this is about triangle law of vector addition. There is another law of vector addition which is known as parallelogram law of vector addition. Let's discuss that as well. In this session, we will be discussing it only graphically, but in the coming sessions, we will be discussing all these laws analytically as well, right? So, another law is parallelogram law of vector addition. Students, as I have told you, it is the extension of triangle law of vector addition. If you are able to understand the triangle law of vector addition, then you won't find any difficulty in understanding this law. So first and foremost point, it is the extension of triangle law of vector addition. Suppose this is the point where these two vectors are acting simultaneously at a point, right? This is the first diagram. Second is, if these two vectors represents the two adjacent sides of a parallelogram at a point, these two vectors which are acting at a point simultaneously be considered the adjacent sides of a parallelogram at a point, which is point O. These are the two adjacent sides of a parallelogram. So definitely, if the two adjacent sides of a parallelogram are known, then by construction the parallelogram can be easily constructed. Parallelogram means opposite sides are equal as well as parallel, right? So this will be A vector. Please indicate this arrowhead. It is absolutely mandatory to indicate the arrowheads. This is the equal vector. This is B vector. So parallelogram means the opposite sides are equal, right? So in that case, if A vector, B vector be represented by the two adjacent sides of a parallelogram at a point, then their vector resultant both in magnitude and direction is given by the diagonal of the parallelogram passing through the same point, right? So O is the point, so this will be the diagonal. So this is resultant. It will be equal to A vector plus B vector. And this is the angle between A vector and B vector. This one is the angle between A vector and B vector, which is considered to be theta, right? So students, again I repeat this statement. Parallelogram law of vector addition is simply the extension of triangle law of vector addition, right? Parallelogram law of vector addition states that if the two vectors acting at a point simultaneously be represented by the two adjacent sides of a parallelogram at a point, then their vector resultant is represented by the diagonal of this parallelogram passing through the same point. Clear, students? Now, why I have said that parallelogram law of vector addition is an extension of triangle law of vector addition, that I will justify. Suppose this is O, this is M, this is N. Consider triangle OMN. Applying triangle law of vector addition, what we get is A vector, B vector. These are the two vectors representing the two sides of a triangle taken in the same order. Their vector resultant would be given by the third or the closing side of the triangle taken in the opposite order. So in this triangle, what do we get? A vector plus B vector is equal to closing side of the triangle in the opposite order, that is R vector. So we get the same resultant. R vector is equal to A vector plus B vector. You can consider this triangle as well. So it will be B vector plus A vector is equal to R vector. So parallelogram law of vector addition is nothing new. It is simply the extension of triangle law of vector addition. Clear? Once again, let me repeat this statement. It is the extension of triangle law of vector addition, and parallelogram law of vector addition states that if the two vectors acting at a point simultaneously be represented by the two adjacent sides of a parallelogram at a point, then the vector resultant both in magnitude and direction is given by the diagonal of the parallelogram passing through the same point. So that's parallelogram law of vector addition. Okay, now students, after covering the topics of triangle law of vector addition and parallelogram law of vector addition, we will discuss the polygon law of vector addition. As the term suggests, polygon law of vector addition will consider more than two vectors to be acting simultaneously at a point. Then how to add those vectors vectorially. So for that, we will make use of polygon law of vector addition. Okay, let's discuss this. So polygon law of vector addition. This is again the extension of triangle law of vector addition only. Triangle law of vector addition, that's the basic law of vector addition, right? Parallelogram law of vector addition, then polygon law of vector addition, they are simply the extension of triangle law of vector addition. Okay, let's concentrate on this particular law. For this, suppose these are the various vectors. Suppose A vector, B vector, C vector and D vector. These are various vectors acting at a point simultaneously or acting on a particle simultaneously, right? So, polygon law of vector addition states that if these vectors acting simultaneously at a point be represented by the sides of an open polygon, taken in the same order, then the vector resultant will be given by the closing side of the polygon taken in the opposite order. So let's do it. Let's draw the diagram. Okay, this is A vector. These are the equal vectors, right? This B vector, what I do is, I will draw a equal vector in such a manner that the tail of B vector coincides with the head of A vector, right? So this is, suppose B vector. I have tried to draw this vector whose magnitude is same as that of this and having the same direction as that of this. So they are equal vectors, right? Now let's draw C vector over here in such a manner that the tail of C vector coincides with the head of B vector. So actually I am drawing the equal vector of C vector. This is C vector. Then draw D vector over there. Again, the tail of the D vector should coincide with the head of C vector. So it's like this. This is D vector. So these are the vectors which are acting on a particle or a point simultaneously. They have been represented by the sides of an open polygon, all taken in the same order, all in the anti-clockwise direction. Then this law states that the vector resultant would be given by the closing side of the polygon taken in the opposite order. So this is the closing side of the polygon taken in the opposite order. These are the sides which are taken in the same order. This is the closing side of the polygon taken in the opposite order. So this is R vector. So here R vector would be given by A vector plus B vector plus C vector plus D vector. So we'll also prove it simply by using triangle law of vector addition, right? So this statement of polygon law of vector addition, right? This law states that when a number of vectors, more than two vectors, acting simultaneously at a point or at a particle, be represented by the sides of a polygon, of an open polygon, all taken in the same order, then the vector resultant, both in magnitude and direction, is given by the closing side of the polygon taken in the opposite order, right? Let us prove it. Suppose this is O, this is suppose small a, small b, small c and small d, right? Let's join these. Okay, consider triangle OAB. Consider this triangle. Look, these are the two sides of this triangle taken in the same order. So the resultant would be given by the third or the closing side of the triangle taken in the opposite order. So this would be A vector plus B vector, isn't it? So over here, applying triangle law, what do you get? OA vector plus AB vector, it must be equal to OB vector. That is, A vector plus B vector is equal to OB vector. That is what I have written. Put this as equation 1. I hope you have understood this. I have simply made use of triangle law of vector addition, right? Now consider triangle OBC. 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 Again, these are the two sides of the triangle taken in the same order. Then the vector resultant would be given by the closing or the third side of the triangle taken in the opposite order. This will be the resultant then. Don't forget to indicate this arrowhead. It's absolutely mandatory, right? So in this triangle, what do you get is OB vector plus BC vector. It would be equal to OC vector. Substitute this value of OB vector, that is A vector plus B vector. This is OB vector plus BC vector. BC vector is C vector. It is equal to OC vector. So OC vector is equal to A vector plus B vector plus C vector. Fine, students. Now last step. Consider this triangle, the last one, remaining one, OCD. So let's consider triangle OCD, this triangle. Again, these two sides may be considered to be the two sides of a triangle taken in the same order. The resultant would be given by this closing side of the triangle taken in the opposite order. So let's apply triangle law of vector addition in this particular triangle. So what do you get? OC vector plus CD vector, it would be equal to OD vector. Now OC vector from equation 2 we can write A vector plus B vector plus C vector plus CD. CD is D vector. It is equal to OD. OD is R vector. So students, we have proved it vectorially, isn't it? So this is how we can easily justify that polygon law of vector addition is nothing but simply the extension of triangle law of vector addition. So students, in the next coming lectures, we will be discussing analytically the triangle law of vector addition as well as the vector parallelogram law of vector addition, right? And we'll discuss all the feasible cases involved in those articles. So I hope whatever we have discussed in this lecture, it is fully understood by you, right? So do join me in my next lecture. Till then, bye bye, and do take very good care of yourself. Thank you.